Hello, space enthusiasts and cosmic curiosity seekers. Welcome back to our channel, where we dive deep into the universe's most intriguing mysteries. Today, we're setting our sights far beyond Earth to one of the most fascinating celestial bodies in our solar system, Europa, Jupiter's icy moon. Thanks to the James Webb Space Telescope, scientists have made a groundbreaking discovery, the first evidence of carbon on Europa. Buckle up as we explore what this means for science, the potential for life beyond Earth, and how it could shape future missions to the icy moon. The James Webb Space Telescope, JWST, has made a groundbreaking discovery on Europa, one of Jupiter's icy moons. It has detected carbon dioxide emanating from the moon's subterranean salty oceans. This revelation is particularly thrilling because, while scientists have long known about the watery depths hidden beneath Europa's frosty exterior, the chemical makeup of these oceans critical for supporting life remained a mystery until now. The presence of carbon, an essential building block of life, in Europa's oceans opens up exciting possibilities about the moon's ability to harbor life. This discovery is a testament to the innovative capabilities of the JWST and its impact on our understanding of celestial bodies. Geronimo Villanueva, a scientist at NASA's Goddard Space Flight Center and the lead author of the research, emphasized the significance of chemical diversity for life. On Earth, life thrives on chemical diversity. The greater the diversity, the better, since we are carbon-based beings. By unraveling the chemical secrets of Europa's ocean, we can assess whether it presents a hostile environment or a potentially life-sustaining one, Villanueva explained. This finding suggests that we might begin to understand the ocean's makeup even before we manage to drill through its icy shell for a clearer picture. The excitement around the James Webb Space Telescope, JWST, continues to build as its advanced near-infrared spectrograph, NIRSPEC, has made a compelling discovery about Europa, Jupiter's smallest Galilean moon. The NIRSPEC instrument, working in the infrared spectrum, helps scientists determine that the carbon molecules found on Europa originated from within the moon itself, not from external sources like meteorite impacts. This finding is far from ordinary. It suggests that the carbon detected on Europa's surface actually comes from its hidden ocean. Carbon isn't just any element, it's essential for life, remarked Samantha Trumbo, lead author of the study and researcher at Cornell University. The JWST pinpointed the highest concentration of carbon dioxide in a geologically young and active area on Europa known as Terra Regio. This region, characterized by its disrupted surface ice and described as chaos terrain, indicates a dynamic exchange of materials between the moon's icy shell and its underlying ocean. This not only deepens our understanding of Europa's geological activity, but also hints at the moon's potential to support life. The detection of carbon dioxide on Europa is tinged with both triumph and a hint of disappointment for Geronimo Villanueva and his team. While they celebrated the significant finding of carbon dioxide, they were also on the hunt for plumes of matter spewing from Europa's surface, a phenomenon the mighty James Webb Space Telescope, JWST, was unable to confirm during its observations. The elusive plumes had been tentatively spotted in 2013, 2016, and 2017. The fact that the JWST didn't spot them this time doesn't necessarily mean they don't exist. Plumes might be intermittent, appearing only under certain conditions, explained Heidi Hamel, a JWST interdisciplinary scientist from the Association of Universities for Research in Astronomy. What we can assert with certainty is that during our observation period with the JWST, no plumes were detected on Europa. Despite this, the discovery of carbon dioxide is a significant achievement, underscoring the impressive capabilities of the James Webb Space Telescope. Hamel, who is also leading the JWST's Cycle 1 Guaranteed Time observations of the solar system, highlighted the efficiency of the telescope. These observations took just a few minutes of the observatory's time, yet they allowed us to conduct groundbreaking science. This glimpse hints at the potential for more incredible discoveries about our solar system with the JWST. The recent discoveries made by the James Webb Space Telescope, JWST, have significant implications not only for our current understanding, but also for future space missions. In October 2024, NASA is set to launch the Europa Clipper spacecraft, embarking on a critical mission to explore Europa and assess whether its hidden oceans might harbor life. Moreover, these JWST findings are poised to enhance the European Space Agency's ESA Jupiter Icy Moons Explorer (JUIC) mission, which launched in April 2023. On a 7.5-year odyssey to not just Europa, but also its neighboring moons, Callisto and Ganymede, both of which host extensive oceans. JUIC aims to delve into the moon's characteristics and Jupiter itself. This represents an exciting initial outcome of what the JWST will contribute to our study of Jupiter's moons, said Guillaume Cruz Mermy, ESA Research Fellow and co-author of the research. The data we're gathering now lays the groundwork for future discoveries about the moon's surfaces and possibly more. The results of this transformative research were detailed in 2 papers published in the September 21 edition of the journal Science, marking a milestone in our exploration of celestial bodies and their potential to support life. The James Webb Space Telescope, a marvel of modern astronomy, has added yet another feather to its cap by detecting carbon on Europa. This significant finding was made possible by Webb's sophisticated instruments, which can analyze the chemical composition of celestial bodies with unprecedented precision. Carbon, often considered a building block of life, hints at the processes that might be happening beneath Europa's icy shell. Let's delve into how Webb achieved this and why it's crucial for astrobiology. Carbon is more than just a chemical element. It's a fundamental part of organic molecules, which are necessary for life as we know it. Finding carbon on Europa raises questions about the moon's geology and the possibility of a subsurface ocean. Could there be life lurking in those dark waters? We'll look at the implications of carbon's presence and what it suggests about the moon's capacity to support life. The discovery was made using Webb's NIRSpec and MIRI instruments, which can observe in near and mid-infrared wavelengths. These tools are especially suited for detecting the signatures of various compounds, even through Europa's thick ice crust. We'll explore how these instruments work and their role in future explorations, providing a glimpse into the high-tech world of space telescopes. This discovery is set to influence future missions to Europa, including the planned Europa Clipper mission by NASA. Scheduled for the 2020s, this mission aims to further explore Europa's ice shell and underlying ocean. We'll discuss how the findings from Webb might shape the objectives and technology of these future missions, potentially opening new doors in our quest to find extraterrestrial life. The presence of carbon on Europa has broader implications for the field of astrobiology. As we continue to discover the building blocks of life on other worlds, our understanding of life's diversity and its origins continues to evolve. We'll consider the impact of these findings on our search for life in the cosmos and how it alters our perspective on our own existence. Europa isn't the only moon in our solar system that intrigues scientists. Moons like Enceladus and Titan around Saturn also show signs of chemical complexity. In this segment, we'll compare Europa's carbon findings with the organic-rich plumes of Enceladus and the methane lakes of Titan, providing a broader context to the potential for life in our solar system. To understand the significance of carbon on Europa, it's essential to look at the role carbon plays here on Earth. Carbon is the backbone of all known life forms, from the simplest microorganisms to the most complex plants and animals. We'll discuss carbon's key roles in biological processes and why its presence on Europa is a game changer. The technology developed to study Europa and other celestial bodies often finds applications back at Europa. This icy moon presents extreme environmental conditions that any life forms would need to adapt to. We'll delve into Europa's sub-zero temperatures, radiation exposure from Jupiter, and the potential chemical energy sources that could sustain life painting a picture of a harsh yet possibly habitable world. Europa has fascinated astronomers and sci-fi enthusiasts alike for decades. This segment will trace the history of our fascination with Europa, from early telescopic observations to its prominent role in science fiction, culminating in the modern scientific research ignited by space missions and telescopic advancements. Exploring Europa is fraught with challenges, from the technical difficulties of landing on an icy surface to the problem of drilling through possibly kilometers-thick ice. We'll discuss the engineering feats required to explore Europa's ocean, the risks involved, and the strategies that scientists are considering to overcome these obstacles. Europa is just one of many worlds that might host carbon-based life. This segment expands our gaze to exoplanets and other solar systems where conditions might be right for carbon-based organisms. We'll explore what the discovery on Europa tells us about the potential for life elsewhere in the galaxy. The potential discovery of life on another world brings with it not just scientific excitement, but also philosophical and ethical considerations. What does it mean for humanity if we are not alone? This segment will explore the implications of finding life on Europa for our understanding of life, ethics in exploration, and our place in the universe. Scientific discoveries often come with unexpected twists. What might scientists find beneath Europa's ice that could surprise us? This segment will discuss the potential for completely unforeseen discoveries and how scientists prepare for the unknown in missions like these. Europa's surface is characterized by a dynamic and complex geological history. In this segment, we'll examine the evidence of geologic activity, such as ice tectonics, cryovolcanism, and the potential hydrothermal vents beneath its icy shell. Understanding these processes is key to assessing the potential habitability of Europa's ocean and the role carbon might play in its subsurface ecosystems. Space exploration has a profound impact on public interest and enthusiasm for science and technology. This segment explores how high-profile missions like the James Webb Space Telescope and discoveries such as carbon on Europa fuel public imagination and inspire the next generation of scientists, engineers, and ordinary citizens to look up at the stars with wonder. The study of Europa is not just a task for astronomers, but involves an interdisciplinary team of scientists, including geologists, chemists, biologists, and even philosophers. This segment discusses how different scientific disciplines converge in the study of Europa, each providing unique insights that help us piece together the puzzle of this intriguing moon. Exploring distant moons like Europa requires substantial funding and resources. In this segment, we'll delve into the economic aspects of space exploration, including how missions are funded, the role of international cooperation, and the economic benefits of investing in space science. Communicating with spacecraft billions of miles away presents significant challenges. This segment will focus on the advanced communication technologies used in deep space missions, including the Deep Space Network, and how these technologies ensure data from distant moons like Europa is transmitted back to Earth. The private sector is playing an increasingly important role in space exploration. This segment will explore how companies like SpaceX and Blue Origin contribute to missions that could explore Europa and other celestial bodies, potentially accelerating the pace of discovery and lowering costs. As we uncover more about our solar system, the need for scientific literacy becomes more apparent. This segment will discuss the importance of educating the public on space science, how discoveries are communicated, and the impact of misinformation in shaping public perceptions of space exploration. Exploration of celestial bodies, like Europa, also involves navigating complex international treaties and space policies. This segment will outline the legal frameworks that govern space exploration, including the Outer Space Treaty, and discuss the ongoing debates over space sovereignty and the exploitation of extraterrestrial resources. If life is discovered on Europa, should humans attempt to terraform it for future colonization? This segment tackles the ethical questions surrounding terraforming, including the potential risks to indigenous ecosystems and the moral implications of altering another world. As we look to future missions to Europa and beyond, advanced propulsion technologies become critical. This segment explores the cutting-edge propulsion methods under development, such as ion thrusters, nuclear propulsion, and the theoretical concept of warp drives. Understanding these technologies helps us grasp how future missions might reduce travel time and expand our reach within the solar system. The discovery of carbon on Europa significantly enhances its profile as a candidate in the search for extraterrestrial life. In this segment, we dive into the field of astrobiology, the study of life's potential in the universe. We'll examine the tools and techniques used to detect signs of life and how scientists prepare to study samples that could contain extraterrestrial organisms. What happens to our societal, philosophical, and personal frameworks if we discover life beyond Earth? This segment considers the psychological and cultural impacts of such a discovery. From potential shifts in religious and philosophical beliefs to changes in our collective identity and priorities, the implications are vast and profound. Exploring icy moons like Europa requires specially designed spacecraft capable of surviving harsh environments. This segment focuses on innovations in spacecraft design, from materials that can withstand extreme radiation and temperatures to robotics and AI systems that can autonomously navigate and conduct scientific experiments in remote or harsh conditions. As technology advances, so does our ability to simulate and visualize space missions. This segment explores how virtual reality, VR, and augmented reality, AR, are used to plan missions, train astronauts, and even allow the public to experience the conditions on distant moons like Europa. These technologies are not only tools for preparation, but also powerful educational resources. Satellites play a pivotal role in our understanding of planetary bodies. This segment discusses the types of satellites used to study moons like Europa, focusing on their instruments, the data they collect, and how this information is used to build a comprehensive picture of their geological and atmospheric characteristics. With the vast amounts of data collected by missions like the James Webb Space Telescope, data analysis becomes a crucial skill. This segment highlights the techniques and technologies used to analyze space data, including machine learning and complex algorithms, and how they contribute to our understanding of findings like carbon on Europa. Space exploration is increasingly a global endeavor. This segment examines the importance of international collaboration in space missions, how different countries contribute to and share the burdens and benefits of space exploration, and the role of international agencies like the United Nations Office for Outer Space Affairs. As we continue to explore outer space, sustainability becomes a crucial consideration. This segment addresses the sustainability practices in space exploration, including the minimization of space debris, the use of environmentally friendly technologies, and the ethical considerations of planetary protection protocols. What does the future hold for space exploration? This final segment speculates on the next 50 years of exploring the cosmos, considering upcoming technologies, potential missions, and the evolving goals of humanity's quest to explore the unknown, including the prospects of permanent settlements beyond Earth. In this segment, we delve into the evolution of space telescopes from the Hubble to the James Webb Space Telescope and beyond. We'll explore how each generation has expanded our view of the universe, the technological advancements that have made these leaps possible, and what the future holds for observational astronomy. As we plan for longer missions, perhaps even to Europa or Mars, understanding the effects of microgravity on human health is crucial. This segment discusses the research conducted on the International Space Station, the physiological changes astronauts experience, and the countermeasures being developed to ensure astronauts can maintain their health on long-duration space flights. Space weather, including solar flares and cosmic radiation, can have significant effects on space missions. This segment covers how space weather is monitored, its impact on spacecraft and human astronauts, and the technologies developed to mitigate these risks, ensuring the safety and success of missions to distant moons and planets. With the discovery of valuable resources on moons, like Europa and asteroids, space mining is becoming a hot topic. This segment examines the economic implications of extracting resources like water, precious metals, and minerals from celestial bodies, the technologies being developed for space mining, and the potential legal and ethical challenges. While much of space exploration looks outward, many missions also provide significant benefits back on Earth, particularly through enhanced Earth observation. This segment explores how satellites help monitor climate change, natural disasters, and urban development, and how this data can be used to address global challenges. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.